Gas exchanges and blackout. What induces the gas molecules to pass through the capillary walls? It is their different density on either side of the wall. For example, if the blood is rich in oxygen while the tissue beyond the capillary wall is poor, the oxygen molecules move from the blood to the tissue. The opposite occurs in the lungs. In fact, inside they look more like a sponge than a balloon. There are thousands of small air pockets called alveoli. When we inhale, the alveoli swell and fill up with air. The blood present in the capillaries that surround each alveolus is poor in oxygen and therefore draws its molecules from the alveolar air. After some time under the water, however, the air in the alveoli also becomes low in oxygen. The body reacts by contracting the diaphragm, diaphragmatic contractions, to mix up the air contained in the lungs. Therefore, air a little richer in the oxygen comes into contact with the wall of the alveolus. However, if you continue the breath-holding dive, after a few diaphragmatic contractions, the effect of this internal shake-up is no longer effective and oxygen no longer arrives in the blood and therefore in the tissues. As a consequence, you suffer a blackout. A blackout is in practice fainting, which in water can be dangerous, especially if you're alone, because it could lead to drowning. Furthermore, the density of oxygen molecules present in an alveolus depends on its volume. When the pressure decreases on ascent, the volume of the alveolus increases and the oxygen molecules become more sparse. By prolonging the free dive beyond your limits, you could suffer a blackout right in the last meters of the ascent when the air pressure in the alveoli decreases rapidly.